In this brief video, we'll show how to properly use Agilent's Infinimax active probes with multiple probe heads to connect to your high-speed signals under various probing use models. We'll begin by showing how to use Agilent's browser probe head under both handheld and probe stand use models. We'll demonstrate the use of our solder-in probe head, including how to properly replace damaged damping resistors. We'll show how to use the socketed probe head using various connection schemes. We'll then conclude with how to use the SMA probe head. The most common use model for an oscilloscope probe is either handheld or probe stand probing using a browser probe connection. The first step is to connect the browser probe head to an Agilent 1130 series probe amplifier. Next, ensure that the probe head has the replaceable probe tips installed. These probe tips include embedded damping resistors to help eliminate in-band resonance and also limit effects of probe loading. To enhance the usability of this probe head and amplifier assembly, you can also attach the ergonomic probe sleeve that joins these two components together, making it easier to hold in your hand as a single unit. Using the levers on the sides of the browser probe head allows you to easily adjust the probe tip span to the correct spacing to fit the test points of your device under test. When connecting to a device's test points, we recommend you connect at a near perpendicular angle, then apply enough vertical force for the spring compression of the probe tips to depress. For hands-free probing applications, the browser probe head can also be used in conjunction with a probe stand holder. Here we see an Agilent Easy Probe Positioner consisting of a precision articulating arm and a user-friendly joystick for easy and accurate probe positioning. First, ensure that the browser probe head and amplifier are properly secured to the articulating arm. In this case, we have simply used tie-wrap straps to tightly secure the probe onto the articulating arm. Now, using the joystick control, simply position the probe tips onto the desired test points at a near perpendicular angle, making sure to apply sufficient vertical compression for a reliable connection. We now have a hands-free probing solution without employing a permanent or semi-permanent connection. Use of a solder-in probe head is often necessary to access hard-to-reach test points, such as probing between tightly spaced DIMM cards as shown here. In addition to being the highest fidelity and least probe loading solution, the solder-in probe head connection also provides an inexpensive hands-free, semi-permanent probing connection. Here's how to properly connect this probe head to your device under test. Using a high-powered magnifying glass or microscope with illumination, first tin the desired test points on the device using a fine-tip, low-power soldering iron. Next, dab on a small amount of flux onto each tinned test point. You're now ready to attach solder-in damping resistors to the pre-tinned test points using the soldering iron. Note that it takes only a brief application of heat to securely solder these small 8 mm diameter axial resistor leads onto the test points. To keep the solder joints from breaking due to weight stress from the probe's amplifier and cable, we suggest you secure the probe head cabling onto the circuit board. In this case, we have simply used a small strip of cellophane tape. Here, the use of small Velcro straps can also be very useful to ensure our probe connection remains secure to the board as it's installed onto the device under test. With the solder-in probe head securely attached to the device under test, you're now ready to configure your system and attach the 1130 series amplifier to the probe head and begin making measurements. Although the solder-in probe head comes with small damping resistors pre-attached, these damping resistors will eventually break with multiple use. This is an example of a solder-in probe head with one of the damping resistors missing. Fortunately, replacing a missing damping resistor is easy. Suggested tools to use include an X-Acto knife, tweezers or very fine point needle nose pliers, a fine tip and low power soldering iron, a solder flux stick, solder, and a small clamp. We also recommend using either a high-power illuminating magnifying glass or microscope. Using the template provided with the replacement damping resistor kit, trim the length of the leads of the damping resistor using your tweezers and X-Acto knife. Next, using the template as a guide, bend one of the leads at a 90-degree angle. It is the bent end of the damping resistor that will be inserted and soldered into the through hole of the solder-in probe head. Here's how it's done. With the solder-in probe head secured by a small bench clamp and working under visual magnification, first tin the through hole connection on the probe head using your fine-tip soldering iron. Then, after applying a small amount of flux, insert the bent end of the trimmed damping resistor into the through hole of the small PC board of the passive probe head. You're now ready to begin using this repaired probe head for your solder-in probing applications. For probing applications where a 20 mil diameter damping resistor can be connected to a device's test points, a socketed probe head may be the best probing option, providing versatility along with hands-free probing. Here we see a 20 mil diameter damping resistor already soldered onto one test point. To make a differential measurement, we'll connect another damping resistor onto an adjacent differential test point of this IC package. Begin by first tinning the test point using a fine-tip low-power soldering iron and solder. Then apply a small amount of flux. Next, solder the pre-trimmed 20 mil axial damping resistor onto the test point. An Infinimax socketed probe head can now be easily and securely attached to the properly spaced axial damping resistors, and you're ready to make a measurement. Alternatively, rather than soldering damping resistors onto device pins, if your PC board has designed-in through-hole test points with a 100 mil spacing, you can simply solder your damping resistors onto these through-hole test points. With pairs of differential damping resistors pre-soldered onto your PC board, you can quickly move your socketed probe head from one pair of test points to the next. You can also connect the socketed probe head to a header connector using a special adapter that includes embedded damping resistors. However, we suggest that you carefully account for the effects of the added inductive and capacitive parasitics of the header connector before designing this component into your circuit for testing purposes. After connecting the socketed probe head to the 100 mil spaced axial pins of the header connector adapter, connect the adapter and socketed probe head to the 100 mil spaced header connector square pins. You can now connect the amplifier to the socketed probe head and begin making measurements. When differential SMA connections are available for testing signals intended to be terminated into 50 ohms, one option is to use standard SMA cabling terminated into two different channels of your high-speed oscilloscope. Use of waveform math can then compute the differential signal. Another option is to use Agilent's differential SMA probe head. Not only will this solution free up an oscilloscope channel for other key measurements, it also provides for a higher common mode rejection of differential measurements, compensates for gain errors due to cable loss, and eliminates the need to de-skew delays between channels of the scope. Here, we're connecting an Agilent differential SMA probe head to two SMA connectors on a board. As you can see, we can easily adjust the semi-rigid coax for variable span dimensions. A major advantage of Agilent's SMA probing solution is that it does not require a dedicated and expensive SMA probe. The same amplifier used in this probing application can be used with various Agilent probe heads for multiple use models, providing a very cost-effective and flexible probing solution. As you well know, the key to achieving the highest fidelity probing measurements is keeping the connection length as short as possible. Agilent's Infinimax probe head technology has been designed to successfully accommodate a variety of common probing scenarios, enabling you to minimize connection lengths while realizing reliable and repeatable probe connections. For additional information about Agilent's Infinimax differential active probes and high-speed digitizing oscilloscopes, go to www.agilent.com/find/Infinimax.